Let us have some historical perspective of software development. It is a lightweight perspective, very easily presented. I cannot present the whole history simply, it's huge. But from the process model perspective, what is interesting for us on this course? So we have had different life cycle process models, and here I have some of them. I will not discuss them now. I'm just presenting the names. Maybe I will exemplify the first two or three. At the beginning of software era, and it is sometime in 1950s, 1960s, so we did not have this profession of software engineer. This term software engineering did not exist. We had a profession called a programmer, and there was no education within programming. So let us say some physicians, mathematicians, amateurs of any kind who were interested in programming, they worked as programmers. At that time, the word developer did not exist. And what did they do? Well, they created simple code, often some mathematical function that had to be codified, or some minor function like, trying to find out how much salary should be paid to employees, salary systems. So they did not have any process models. I mean, the code or the programs were so simple, so they just simply listened to the requirements of their users, and then they wrote code for the users. Usually these programmers worked for some company. They were employed by that company. A company like, for instance, ASEA, needed to computerize some functionality, and they had their own programmers. And the process looked very simple. The manager came orally, he presented the requirement to the programmer. Could you please count out how much employee benefit or our employees will get at the end of this year? And the programmer sat at the computer and wrote code. Then he fixed the code and he delivered it. So this was a very simple process model. Also very important is that at that time, no one documented code, and all communication about the programs took place in an oral way. So it was an oral communication. Please observe that documenting is also a communication, but it's written communication. So you communicate about a system. If you describe a system, you document it, and this is a type of written documentation. If you talk about the system, then it's type of an oral communication. Yeah? But with the time, these programmers, they became more and more important. And how come? Well, this is because more and more companies realize that if they do not computerize, they will be out of business. So this was quite a stressful time, I can tell you. But still, we did not have professionals who could do the job. And please observe, I told you before that anybody could work as a programmer as far as he was good at it and was interested in it. So chemists, geologists, whoever did the job. But of course, at that time, there was no such subject. There was no theoretical basis for how to program, etc. So these programmers had huge difficulties. Why? Because when the programs became more and more complex, the more problems these programmers got. I mean, there were more bugs hidden, and which were difficult to identify and solve. And also companies became more and more reliant on software and also on programmers. That's why this figure shows how managers were kneeling in front of programmers and begging them to do the job. These were very good times. I remember when I was a student, I worked for Dagens Nyheter. There I sold a daily subscription for the newspaper. And I remember one of the guys, he had hardly any education, but he went on a course in 9 months, I think, in COBOL, the programming language by that time. And one day he came to us and told us that now I'm going to work as a programmer and I will earn that much money and I will have such and such employee benefits. When we heard all this, we could not believe our eyes. It sounded like heaven and magic. So I, who studied English and Russian at Stockholm University, I quickly realized that it would be better if I could choose some other subject. And here I am. I have chosen computer science and software engineering. So these guys became more and more important, but the code did not become better and better. On the contrary, the code became very complex. It became so complex that in 1968 there was a conference, a NATO conference, which met where individuals, the software professionals by that time, met in order to discuss the software crisis. We had a software crisis, and what does it mean? Well, it means that we created a lot of software, but we spent a lot of time and money on that software, and many times we could not deliver this software. The software was not simply possible to use. It had too many defects, or it did not give the user what he wanted. So that's why we had this NATO group meeting, during which the problem of software crisis was discussed. And after that meeting, there was one German guy who suggested that we should actually have a discipline for that area, and we should call it software engineering. And please observe that this phrase was deliberately chosen to be provocative. And why? If I may come back to the former slide, because these programmers were far from being engineers. They had hardly any education at all within this. They were self-learned. Probably engineering, they did not even know what it meant. So that's why it was provocative, but it would imply that we should have some kind of need to develop software, or software manufacture as it stands here, that is based on theoretical foundations, solid theory, and practical disciplines that are traditional in other engineering branches. So here the term software engineering was born, and this discipline would include knowledge, tools, methods for software requirements, design, construction, testing, and maintenance. So, okay, now we know that we are engineers, but then it means that we have to behave like engineers. What do? Well, we try to look at the process models from other engineering branches and see whether they are applicable within software. And what does it mean? Well, engineers first must find out what are requirements, what it needs to be developed. Yeah. So you have the first step in which you identify all the needs, all the requirements for the new system. Yeah. If you are going to develop an educational system, then you have to find out what are requirements. You need to record information about students, you need to record their grades, you need to have information on courses, and so on. This type of activity, like the requirements definition, is to be collected by requirements teams. It may be one individual or it may be several individuals. Usually these people are called business managers. Business managers are the guys who go around and try to find out what are the requirements. After they have collected the requirements, they provide the requirements to the design team. And now the design team designs the system. They read through requirements, find out how to model or how to design the system, and they create a model of it. After that, they provide the design together with the requirements to another team, which are programmers or developers. And during this time, the developers create code and unit test it. Well, what does it mean, unit test? Well, I will go through it, but let us say that we have several teams of developers. One team developing functionality for managing teachers at a university system, then another team developing functionality for managing students, and so on and so on. And then within this team you have individual programmers, and they create their own code. So this code will have to be tested by these developers by themselves. So what the developers do, they write their own code, and before they deliver it to anybody, they have to test it. Otherwise they may send something that is defective. So after all these teams have developed code, then they send it to testers. And what happens here? Now the code from different teams gets integrated, into one whole system. So the team managing the customers, managing the students, send their own code. Teams managing teacher information send their code. Integration testers integrate them, and then system testers test them. And of course, after that, when the system is tested, it is delivered for operation and maintenance. So this is a model that is taken from other engineering disciplines. If you look at its design, you may see that it looks a little bit like a waterfall, doesn't it? Yeah, well, it does. It is because the output of one phase is input to the other phase. I'm not saying that it's good, I'm just saying that it is like it is. Yeah? Good. So in older days, when this waterfall model was used, or at its beginning, what happened is that the requirements team, as soon as they collected the requirements, then they froze all the requirements. What does it mean? They documented it, they sent it to the design team, and simply it was very difficult to change these requirements. And the same, and then the designers, when they developed their designs, they froze these designs and sent them for the implementation, so the developers could use only those. So no change was allowed. This was not so good, because sometimes you may make mistakes when identifying requirements or when making design. So that's why partly we had also this software crisis, and I don't say that crisis disappeared, but this is one of the reasons why this waterfall model does not always work well, because you are not given the opportunity as it is now. On this slide, you do not give opportunity to go back and do some changes. Yeah. So that's why waterfall model has come under attack. What does it mean? Well, first of all, if we may go back here, so to identify requirements may take time. To design a system may take time, and etc., etc. So time-wise, it takes a lot of time. Also, these groups, requirement team and designer team, may not always talk to each other. They actually talk to each other via documentation. They document the requirements and send the requirements documentation to the designers. Designers design the system and send the design documentation to the programmers. So it's not the best way of communicating. But of course, documenting is very important because you document what the system is about. So why it has come under attack? Well, first of all, to develop a system is a long and painstaking process. Like I've told on one of the former slides that it may take up to 5 years to develop a system, so it may take time. So at the beginning, when you have written requirements, these requirements might be valid 5 years ago, but they might not be valid now. So it's not that very, well, it's not such a good solution just to not to be able to change these requirements. And also, this way of communicating via documentation, it is usually called over the wall. So the wall is that the teams do not sit together. They may be physically located wherever. And this over-the-wall communication is not the best way to create a good quality system. Or you can even call it an assembly line approach. And why? Well, in assembly line, you have one team that creates something, its output is input for another team to create something, and so on. So this assembly line approach is not so good either. But what is good is that each role has its own responsibility, and they know how to do their job. But it does not help you if you have made some mistakes to remedy them easily in such a model. So we have done many attempts to improve development. If you look at this one, this little thing, yeah, okay, this is like waterfall model. You have still the same phases, but what happens is that while you write requirements and analyze them, you also involve testers who write acceptance tests. Acceptance tests, they are tests that are to be conducted by end user, and he has to accept the software system. So while requirements are written, the acceptance tests are written to be then later used by those who test the system. While you design the system, you also write system tests. While you program, you write small minor programs, you also create other integration tests, and so on and so on. Then there was another interesting model. I will have another slide about it. I will just quickly go through it. The whole process model looks like a spiral. So you start somewhere here, yeah, and you just go around. And here, this corresponds to one phase, yeah. And what does it mean? Well, you have some initial set of requirements. So you determine goals and alternatives, constraints for implementing these requirements. Then you try to identify what risks are when you implement these requirements. You should always think of what risks may happen. Like if you want to use some new technology, so you might run the risk that this technology might not work. So here you identify risks and you try to find out other alternative solutions. So alternative solution would be to use simply another type of technology instead of this very innovative one. And then when you have identified risks, you develop and test this part, this set of requirements, and then you plan for the next phase, and so on. And you go and develop more and more of a software system. Then we have incremental development. So you have some kind of requirement specification, but you do not implement everything. You just choose a set of requirements, you implement them, you release them in release 1, and the customer is using release 1, and then you are developing, when the customer is using release 1, you are developing next functionality, which you release together with the first functionality in release 2, and so on and so on. So you continue building up, adding new functionality to the software system. It's called incremental development. And of course, there are many, many other models. There are object-oriented analysis and design models, CBD, component-based development, agile development. I will not go through them right now. Maybe some of them I will explain later on. But if we just go back to a waterfall model, what is interesting is that you have different groups. They may not be physically located, co-located. They simply work sequentially. And this is what software community has realized it does not work. So there, at the end of the former millennium, somewhere in the 90s, there was a group at Toyota developing cars, of course, but instead of, but as I've told you, waterfall model was reused from other engineering disciplines. So they came up with an idea of a multidisciplinary team, which means that you have here business managers, for instance, sitting and gathering requirements. You have developers who take a subset of requirements from the business managers and design them. Then these designs are automatically used by the developers, and the testers do the work as well. So while these business managers have, after they have provided initial set of requirements, they work on a set of next requirements. The designers work on the initial set of requirements, and so on. So everything is almost in parallel, not almost, but almost, not always, not 100%, but almost 100%. And the goal here is to overcome the problem of the traditional sequential product development process. You are losing time simply because after you have created requirement specification, you do not have anything more to do. So the goal here is that you are always busy with the requirements management and you are always providing feedback to other groups. So the phases here are run separately and sequentially, that were run sequentially and separately now are almost performed simultaneously. And there are many models. I will just provide you one way of developing software, which is some kind of a standard for agile software development life cycle. So what it means is that you simply write software system in small portions and deliver it in small portions. This means that you define requirements or initial sets of requirements. You cannot know all these requirements from the beginning. I'm not saying it's good because there have been many problems with that. I'm just telling you how it works. Then these initial sets of requirements are then designed, and then overall design. And then many of these requirements have to be, more detailed, so they will consist of other requirements. And these smaller requirements, more detailed requirements, and these are implemented here in the implementation phase. And what does it mean? Well, what is the difference to the traditional development? In traditional development, when you had this implementation, let us go back there. Yeah, here we have programmers. So they received a specification of what needs to be implemented. And they could develop code for grading students. They could develop, let us say, one individual, one team, develop code for registering students, could develop code for, assigning them course tasks, and so on and so on. The programmers, let's say like that, they had 3 months to develop all this code, and they had the freedom of developing all this functionality in whatever order suited them. They did not need to test anything earlier, but before sending their code for integration and testing, they had to test it. But otherwise, they were free to choose in whatever order. This simply was not so good because many times developers, knowing that they have 3 months on them, they postponed the work, or they did not postpone the testing work, which means that before they would send their code for system integration, and when they started testing their code, they realized that they had many problems. And this, of course, delayed the whole testing process. So in order to avoid this, one suggested to structure implementation into iterations. So now a team would do implementation in iterations. So first you choose a subset of these requirements that you have been assigned, and you implement them, and you test them, and of course you do not deliver them, because delivery you have here after implementation. But what you do, you at least show it to someone to show that it works. And this someone can be either end customer, if this end customer is available and willing to support you, or it can be some customer proxy, which is called product manager, often in the industry, or you can just show it to yourself, to your team. But before you go to the next iteration, you must make sure that the functionality you have chosen for the iteration has been implemented and tested, and so on and so on. So you iterate all the time till you are ready with what has been assigned to you. Then you deliver. Delivery can mean that you again show it to someone. It may happen that this system may not be ready, so you are just ready with initial sets of requirements. They may be delivered to the customer if it's of any use, but if it's not of any use, you may continue with the next set of requirements and continue with the procedure of designing, implementation, and delivery. So at some delivery point, you will realize, okay, this must be now delivered to the customer. Okay, so I have shown you some types of methods, and believe me, we have many different methods today, and we are not that bad in producing software, but we have one problem. We do not have a common ground regarding the theory of software engineering. And what is the problem? Well, if I worked in company having the culture of using a waterfall model, and then I suddenly go and to another company using, for instance, Scrum, then I get confused, because these are totally different methods. The language may be totally different, and it's difficult to say it's difficult to compare these methods because they are so different, and even the terminology used is not the same. So what we need is that we need some kind of a common ground. And this common ground implies that all the methods would be able to relate to this common ground. So common ground stands for what needs to be done within software engineering. And then by checking the methods, checking how much you can do within these methods can always be related to this common ground. This common ground is called the essence. I've told you that CMAT Group has developed a framework or a model that is called essence. Yeah. So this essence is some kind of a kernel of widely agreed elements that you always have in software engineering. And I have already shown you this slide. CMAT essential things. I will not go through them. I'm just repeating that you have it on some other slide. These are the things that are necessary for developing software systems. Like, for instance, if you have all these things but you do not have requirements, then how can you develop a system when you don't know what to develop? Or if you have all these things but you do not have team, then you have no one who can develop a team. If you have all these things but you don't have way of working and a method, well, you probably may develop the software system, but there will be chaos. You want to produce quality, and so on, so on. So these things are very essential. You cannot live without them. You cannot create software without them. So Essence is part of an OMG standard. This is an international standard, and I have been involved in developing it. And it consists of two parts. Essence kernel, the one that is part of this course, and Essence language, which is not going to be part of this course. It is the language helping developers to design processes. And the goal with it is that using the Essence kernel, you may create different practices. Remember from another slide, practices were small processes. And these small processes, then by being integrated, they create a method. So let us say these small processes like programming. This might be one little process. Then you have a process of designing code. You put them together. You have a little process of managing requirements. You put all these together. You may have many very different variants of practices, like within programming, you may have singleton programming where one programmer is involved, or you may have pair programming where two programmers are involved. These are variants. You do the same thing, but these are variants. You choose one of them, and then you create an integrated method for software development. So, okay, so I have shown this picture to you. So what Essence says is that using these essential things, which we have here on the bottom of it, we create practices, and using these practices or integrating them, we create methods.